Okay, here we're looking at the fun equation when it deals with acids and bases, henderson hasselbalch, or hee-haw. Super helpful if it's buffered. If it's not buffered, not very useful. Works when the X approximation is small, almost always is. Rare occasion, again, on your test, your AP test, you might have one mixed together just because of the fact you're on the AP exam, they like mixing things together. X approximation works when the concentrations aren't too dilute and the KEQ or KAKB is very small. 100 to 1,000 times the size of K. Again, that's like 10 to the negative third, 10 to the negative second, 10 to the negative third. Okay. You could do ice tables to do the exact same thing, but they can be really time consuming. And as we know, being a time test, sometimes you want to save precious minutes. A couple different ways you can see these, right? For pH, you've got the pKa, base over the acid. pOH, you're using the pKb, and it's acid over base. You could do it this way, generally not needed. Sometimes it's easier to go and determine what these values are and be able to plug them in as that. The acids or bases may be conjugates from the salt itself. And again, reminders of pKa, pKb, what they mean. Same ideas. pH is equal to negative log. Acid with a buffer, you have the idea it's the salt over the acid, which means we're talking about the conjugate base over the acid. Base with the buffer, again using KBs, conjugate acid over the base. So know your situation and know which ones you can use for that situation. We've got one that looks very similar to what we had before. In this case, the acid solution with salt added. Acid, salt. Remember, the salt has the conjugate base. So if I know the Ka, pKa, plug that in. Log of the base divided by the acid. The base being the sodium fluoride, the acid being the hydrofluoric acid. Plug it in. And that equals my pH. So if I need to determine the hydronium concentration, 10 to the negative, and I have my hydronium concentration. Another way of looking at these, again, rearrange your law of mass action. If we have our equilibrium constants, in order to solve for hydronium and hydroxide, we can move our Ka values around and be able to plug them in there. And that's, again, our acid over conjugate base, base over conjugate acid. Again, could be helpful in different situations. So I suggest picking a method and just stick to it. Everything has pros and cons. Ice tables you might be very familiar with. They might be able to churn out pretty quick. They do take forever at times, lots of steps. Hee-haw, fast. It's on the AP equation sheet, so you don't have to remember it. But you have to recognize it, and you're not always solving for pH, so you might have to solve for other things. And therefore, like if you're solving for the concentration, we have just the original. Like if you're solving for this concentration of the acid, you have to do some kind of fun math in order to get there. So that can be kind of tedious or troublesome. Rearranging the mass action, simple, right? You have to recognize how to use it, and you'll have an extra step to get there, although I would say to get that extra step would be not so hard, because again, if you're solving for acid or base, this is far simpler, right? To go, boom, I know this, determine the base, that's the base concentration, which is hydroxide, determine my pH from there. I can do that. So a lot of different ways you can do it. Pick one, stick with it, get used to it. Some suggestions I have, practice all the methods once in a while. Based off the information they'll give you, they can make some problems easier or more challenging. Solving a variety, I give you a variety, but I try not to overrun you, but you can get plenty from the book and of course what you can find online. Fine to use one method on a key, looking at just getting the calculation and then showing work that makes sense to get there. Just be careful about rounding. You know those kind of get messed up with pHs. And again, watch your sig figs when it comes to it. All right. So let me know what kind of questions you have, and I'll talk to you later. Take care.